Hi guys, and welcome to analyzing the general form of any rational equation where m equals n. So just a reminder, so when we're talking about m and n, we're talking about the degrees of the polynomials in the numerator and in the denominator of a rational function. So for example, when we're looking at a here, the degree of the top is this squared here, so we have degree 2 and degree 2. They're equal. Okay, same thing here. We've got degree 2, they're equal, and so we're going to be looking at kind of number 4 here. Okay, but we can start at the beginning because for all rational functions, no matter what, the x-intercepts always are when the numerator equals 0. So let's look at that for a. So this would be when 2x squared equals 0, and 2x squared would equal 0 when x equals 0, because you divide both sides by 2 and take the square root of 0 and you end up with 0. Okay, so we would have the x-intercept of 0, and so then remember we always want to write that as a point, and so that would be the point 0, comma 0, because the first 0, the x, we get from the equation that we did, and then at your x-intercept, y is always 0. Okay, so now let's go ahead and do the exact same thing for b here. Okay, so we're going to take our numerator and we're going to set it equal to 0, so negative 5x squared minus 2 equals 0. So we would add 2 to both sides, and when we do that, we get negative 5x squared equals positive 2. Okay, and then when you divide both sides by negative 5, you're going to end up with x squared equals negative 0.4. Now, you can't have a number that's squared that equals a negative number, and so what this tells us is that our second equation here is going to have no x-intercepts, okay? So the actual answer here would be none, because when we tried to solve this for x, we ended up with a negative number here, which means that we can't actually find any x's that will work here. Okay, so let's go ahead and move to the vertical asymptotes. So the vertical asymptotes are very similar. Alright, so then you're setting the denominator equal to 0. So let's go ahead and go back to our first equation here. So we have x squared minus 16 equals 0. So we would add 16 to both sides to solve, and you get x squared equals 16, and then of course you take the square root of both sides and you end up with a vertical asymptote of x equals positive 4 and negative 4. So remember, either of those we could square to end up getting 16. So for a, the vertical asymptotes are x equals positive 4 and negative 4. And then for b here, we're going to do the same thing. So we've got 2x squared minus 24 equals 0. You would add 24 to both sides to get 2x squared equals positive 24, and then divide both sides by 2 to get x squared equals 12, and then take the square root. Now, when you take the square root of 12, that's not a perfect square, so you're going to end up with a decimal, and so we've got about 3.5. So x is going to be about, again, we need both the positive and the negative, so it's about positive 3.5 or negative 3.5, either one. Okay, both of those. And so now let's go ahead and look at the horizontal asymptote. So this is what's a little bit different, but it's not very hard. So when m equals n, then the horizontal asymptote is just the leading coefficient of the numerator divided by the leading coefficient of the denominator. And what that means is whatever the coefficient is with the degree, that's the leading coefficient. So you divide those. So for a, it would just be 2, so the leading coefficient of 2, y equals 2 divided by the leading coefficient of the denominator, which is 1. So just y equals, 2 divided by 1. So just y equals 2. And then for our b here, we're going to do exactly the same thing. Okay, so the leading coefficient of the numerator is 5. So we get y equals negative 5 divided by the leading coefficient of the bottom, which is 2. And negative 5 divided by 2 is y equals negative 2.5. And that's it.